Leonardo da Vinci's Vitruvian Man. Two ways the same theorem by Giles Towning. This picture shows the perfect proportional man fitting perfectly into a square and a circle. For the first time, Leonardo draws the Vitruvian man with the centres separated. Keeping the proportions of the man seems more important to Leonardo, and therefore the square and the circle are also proportional to the man. There are some hidden mathematics within the drawing, a 500-year-old puzzle experts have been unable to fathom. Two symmetrical halves of the man, left and right, have intriguing differences. The two toes, pointing towards and addressing the viewer, have equal distance between them, and the circle and the square crossing point next to them. Only one hand has a straight finger and fingers touching the side of the square. These points were highlighted in a previous documentary. On the surface, the ancient Greek squaring the circle challenge does not add up, as the areas of the square and the circle are different. Let's calculate these differences, as this is significant. And these measurements are for this scale drawing only. And squaring the circle from the side to the radius gives you this formula, and squaring the circle from the radius to the side gives you this formula. And as you can see on these calculations, the sides don't add up, the areas don't add up, and the radius don't add up. Origami helped me find the right frame of mind to find the breakthrough clue. I'd worked out a folding sequence to find the diameter radius from a circumference on a square. This is 99.6% correct. I wondered, could I adapt this folding matrix to square the circle? This folding sequence is 99.96% correct, so you can get very close to pi, but it's impossible to calculate the area of a circle due to the nature of the number pi. The radius length ratio to the square was the clue. From these highlighted points, I recognised C and D could be the radius to square the circle of the square. I made the calculations, and it is. But what about the circle? I slept over this question and realised that the length EF could be the length of the side of the square to square the circle of the circle. I made the calculations, and it is. These two lengths, hidden in plain view, show the two different directions to calculate squaring of the circle, from a radius and from a side of a square, two ways the same. Maybe Leonardo left a trap for academics to fall into. He could claim that in this picture I've squared the circle, and of course he'll be humiliated at being proven wrong, and then he could prove himself right and correct above all others. Indeed, they have fallen into this 500-year-old puzzle trap by dismissing the squaring of circle theory and channeling their thoughts into believing there must be something else mathematical hidden in there. But what is, and they've ended up hypnotising themselves into missing the obvious. More questions could be answered though. If the man is in perfect proportions, in the standing position, his feet are at right angles to each other, like standing on a 90-degree set square. This is a natural position for a man with flat feet, but this man clearly has good arched feet. And what is this new angle that's appeared? Ironic that origami, the very poor man of maths and art, should lead to the unlocking of one of the most priceless works of maths and art. Don't live in denial, try it out for yourself. 2 ways, the same theory. You've heard it here first. Thank you very much for listening.